Right.
Max, want to start us off?
Yeah, let's do it. All right. Welcome, guys. This is the CAD workshop for the RSC Makerthon. Super excited. Let's go. Let's get right into it. Some quick introductions. Alan, go ahead.
Yeah, my name is Alain Zhiyanov. I'm a mechanical design student. Specifically, I've done a lot of CAD for our robotics team, FRC 7461. I also do some projects on my own. I have a 3D printer. I print PPE. I do all kinds of sorts of CAD for that. So yeah, really excited to get started with this and share my experience.
Yeah, I'm Max Wang. I'm the uh, first robotics competition 7461 team sushi squad design lead. And, I'm super hyped to work with Alan to put together this presentation for you guys, this workshop. Let's get started.
Right. So first, before we get into what CAD is, we kind of have to get into what mechanical design is, and that's kind of the more broad sense of where to use CAD. And mechanical design, it's a broad field, and it's basically how to engineer solutions to problems around the world. So that means creating different mechanisms and planning out these mechanisms, creating these mechanisms, fabrication. So CAD, it goes into kind of the preliminary stage of planning these mechanisms before you actually create them. And then someone will go and fabricate them. And it's a very important industry skill. A lot of people go into this in engineering and so on. And CAD is a very important component, which we kind of introducing you guys to here.
Right. Yeah. Alan kind of touched upon this a little bit, but let's talk about what is CAD. And CAD is just a tool. It's a planning tool, right? That mechanical designers use to model complex parts and mechanisms. You use CAD to lay down geometry with sketches, and then we manipulate those sketches to create complex profiles from which we can build complex parts. So CAD helps us plan how different parts can fit together as well. So maybe if you have a lot of different parts that make up like an engine, right? A car engine. You have to figure out how those parts interact with each other to have a cohesive idea of the whole engine itself. And so CAD allows us to do that more easily than maybe like pen and paper design. And it also helps us document our prototyping because I'm, I think the next workshop is actually the prototyping workshop, but where you learn more about prototyping. But prototyping is a really important part of mechanical design, just iterating and improving upon your design. And so CAD helps us document that.
And so finally, what is the purpose of this workshop? Well, first, let's start talking about what is CAD in the scope of this competition. And CAD can actually be really powerful in this competition. So let's say you're someone who maybe doesn't have that much experience with CAD. Even in that case, it can be really helpful. So if you are able to maybe create a supplementary part to your solution with CAD, that could really boost your score in some categories. For example, clarity and details. You can really be specific with what you're trying to get at with your design. So you can use this presentation to kind of to expose yourself to what you can do and maybe go forward with supplementing your submission with CAD. And so who is this workshop for? This workshop is for people who have never used CAD. Maybe they know what it is, but they never really used any of the software. Or maybe it's for someone who has some preliminary CAD knowledge, but doesn't know how to use Onshape or has never used Onshape. Today we'll be going through the basics of Onshape, so we'll be happy to expose you to what that is. And so this presentation will be very, very fast paced just because we have an hour and there's a ton of tools to get through. So take this more as kind of an exposure of what CAD can do rather than how to use it. And if you would like to use CAD in this competition, we'd highly encourage you to please follow along on your own Onshape account. Someone sent that on the Discord server earlier that how to create one. If you guys haven't done that already, please do that before we start. And yeah, so you can also use the Onshape learning pathways if you want to kind of get more in depth into some of the things we're going over. That can just be accessed in your Onshape account under Learning Center, and there are a couple Onshape pathways you can go through. And finally, go ahead and ping us, both me and Max and Abby, for example, on the Discord server, on the RSC one. and we can help you out with CAD. We can help you out how to supplement your submission of CAD, or how to even CAD your whole submission. So yeah, let's get going. I'm going to go ahead and get to our CAD document.
Here, Alan, I'm just going to screen share right now.
Oh,
all right. All right. Yeah. So let's just talk about sort of, an intro to Onshape. Just get you guys used to the UI and how to make yourselves your first document where you can start working on CAD. So this is your Onshape documents like homepage, essentially. This is where you can navigate through our documents. Chances are, if this is your first time using Onshape, you probably don't have many documents. That's okay. So usually how you make your document is you click this big blue button over here, create, drop down menu. You can create a document or a folder for your different documents. You'd create a document here. But because we actually have a document set up between me and Alan that we have shared access to, so we're just going to go right into that document. So let's pop right in. Okay. Cool. So right off the bat, you guys can see that there are two kind of types of these little tabs down here. They're part studios, shown by this little graphic with the two rectangular prisms, and then the assembly, which has this sort of graphic. And we'll talk about assemblies later, but part studios are where you build your individual parts from profiles, build them up, and then assemblies are where you assemble all these parts into a whole product. Yeah, we can just start with part studios. If you see here, I clicked into the part studio number 1 here. That's a default name. We can change that later if we want. And the first thing you'll see are these 3 planes and this point in the middle. So what these 3 planes are, they are basically the basis, the foundation of your part studio. This is where you'll build all your profiles up from, and it's just the very basic resource that Onshape gives you to start. And if you see here, I'm scrolling kind of through them. They're you can see them moving through space, and just some quick tips on how to do this, because it might be a little hard to get oriented at first. So your left click actually isn't a drag. Your left click is a sort of select, as a group select. So if you just left click drag, you'll highlight a lot of things, you'll select a lot of things. But then you have to, in order to twist your UI around and do all sorts of this sort of stuff and navigate around, you have to use your right click. So just to clarify and make sure no one's confused. And then if you want to just pan back and forth like this, you click your middle mouse button. So that's usually your scroll wheel. So you click that down and you can drag it around. And then some more, I guess, helpful tips is that in the corner up here, there is this cube looking thing with axes on it. And this allows you to really easily navigate around your sketch. So you can click all these different faces of the cube to get to the different faces of your part studio. Yeah, just want to put that out there first, because I know the navigation Onshape was a big learning process for me at first. So moving on, let's go back to planes. So planes, as I mentioned earlier, it's where you build your profiles from. You can, and we'll talk exactly why these planes are super important. And then this dot here is called the origin. It's like in math, the Cartesian plane. The origin is where everything starts off of. It's like the 0 for your Cartesian plane. It's also the point which you can define all your sketches to in relation to. So it's here. It'll make more sense once we start. Alan, why don't you start us off with some sketches?
All right, Max. So before we actually start with the sketches, I want to kind of take a step back and talk about what we're going to do with all these sketches. And what we're actually going to do is we're going to actually create a very basic solution to our competition. Our competition is restaurants and COVID, and I've 3D printed a small tool here, which I've actually CAD'd last night. And what this is, basically, you might have seen these before. It's it lets you open doors and kind of press on keypads without actually making contact with them. So it's COVID safe. And so why this is very beneficial to us is you can actually completely CAD this in Onshape, and then you print it out just by exporting the file and slicing it and printing it. So what we'll be doing is we'll actually be creating this, going through the steps, and seeing how CAD can be helpful in creating a submission for this project. So let's get started here. Let me go ahead and start screen sharing. Give me 1 second. There we go full screen. There we go. All right, so as Max was saying, first, everything in CAD kind of follows the same order. You go from a 2D space to a 3D space. And what we'll be doing first is we'll be creating kind of a 2D profile of this tool here, and then we'll be later extruding it into a 3D space and working with it there. So that brings us to, how do we create this 2D profile? How do we create this 2D kind of outline of this tool? Well, what we do is we go into the sketch environment, and you'll see that automatically this window pops up and it prompts us to look for a sketch plane. It shows up blue and it asks us to pick a sketch plane. All this means is, where do we want to actually draw this 2D outline? Let's say I want to draw it like kind of aligned with the floor on the top plane. And there we go. We've clicked on that. And now we've entered the sketching UI. As you see, there are a lot of tools up here. We have the same kind of navigation as we had earlier in the 3D space, 3D part of the Part Studio. And we have a sketch that pops up here in our feature tree. So the first thing we're going to kind of do is get a line for our sketch. And that means going normal with your sketch. You can just do that by pressing N on your keyboard. And you show up kind of on the bird's eye view of your sketch. And so now we're going to go through the tools kind of left to right and go over what each one of them does. As I said, this tutorial will be very fast paced. We won't get through all the tools just because there are so many and we have little time. So if you would like to get more in depth with some of these tools, you can, again, ping us or use the pathways, which can be found here in the Learning Center. So let's get started. Oh, one more thing. So usually what you do to access these tools is you just press on them in the taskbar. All be just by virtue of habit using some of the shortcuts you can get to. Like, for example, to use a line, you press L, and it's just habit for me to press L. So if you just see me get a line without clicking up here, that's what I did. Just don't get confused by that. And so, yeah, let's get started. So let's start with the line. We'll kind of work our way from left to right. So what a line is, and it describes for some of these what these are, but not for the line, I guess. Line is just as you expect. It's a geometrical line. There we go. I just created it by picking a point and then clicking and dragging. And now we've created 2 different lines. And these lines are just as you expect. There are 2 points connected by a line, just as you expect in geometry. And there's not much to go over here. You can move around the points, as you see. They're not really defined right now. And you'll see that, you can already start seeing, like, we can use these lines to make this profile, right? We can connect these points and get a simple profile. But we need to get it pretty close to what we're getting here. So we need some of the other bodies. So let's keep going. We have the rectangles, which are really just a series of lines, but Onshape kind of has a preset for them, and they're constrained off of each other and how you'd expect a rectangle to be. And there are 2 different types. First is a corner rectangle. You see it describes what it is. Corner rectangle basically means that you can pick a point and click and drag and from the corner, and you create a rectangle. And a rectangle, just as you expect in geometry, is a series of lines which are parallel to each other, or opposite sides are parallel, and the adjacent lines are perpendicular. So you see they're already constrained off of each other, which we'll talk about later what that means. But basically, no matter how I move this, these will always be parallel to each other. And you can see that the shape is enclosed because it is gray on the inside. Let's go over the rest of these. And the center point circle, I forgot to mention, just a rectangle, except you go on from the center instead of from the corner, and just click and drag. And again, you can move these around. Let's keep going. We have the circle. And just as you expect, you pick a center, you drag out, and you have a circle here, just a geometric shape as you'd expect. And the last body we'll go over is a 3-point arc, which you select a start point, you select an end point, and you select a radius just by clicking and dragging here. And look, we have all these bodies, and you can already start seeing that we can use these bodies to create this 2D profile here. But these bodies aren't connected and they aren't dimensioned. So it's a little bit not done, as you can say. So we have some tools we need to keep going over. So I can go ahead and delete these and actually start working on this profile. So let me go ahead and open this up. Just one moment here. All right. So yes, I'm just going to go ahead and start working on this door handle here. So I'm going to create this little L shape right here, and we'll work our way through learning what dimensions and constraints are. So I'll just hold this up, I guess. So I'm going to create that leftmost L. And for now, and you see the Onshape is kind of auto-correcting me here. There's some constraints. These are very useful, but I'm going to go ahead and ignore them on purpose just to show you how to use constraints. So this L is going to look a little weird for now. Oh, I messed up. One of them's already constrained, but that's okay. And so you can see we have a very, oh, I need my hand here, very rough L shape here. There we go. So now, as you see, it's not constrained, right? These things need to be perpendicular and parallel to each other and have certain lengths. So we're going to go over these. We're going to go over the constraints specifically. So first, we're going to go over what these are. And basically, these are a series of tools that let you constrain two bodies off of each other in specific ways. Some simple ones are, for example, parallel. Where is parallel? There it is. Parallel just lets you select two bodies, for example, two lines, and set them parallel to each other. So looking at this shape here, you do see that there's some like pointy edges here, but we're going to be making those in the 3D space. So just imagine that there's a square L shape here. You can just go ahead and make this parallel, make this parallel, make this parallel. And you see we're already starting to get something that looks like this L. We can also make these perpendicular by using the perpendicular constraint. Then we just select the constraint. We select the two bodies we want to make perpendicular. And we start to get kind of perpendicular L here. And it looks like those are all the constraints I need. And we're starting to kind of get an L, right? So no matter how I move this shape around, these will always stay parallel and perpendicular to each other. So now we should keep going and make some more constraints. Another constraint you can see is that this line right here and this line are equal to each other. That's another constraint. You can select equal up here and select two bodies, and their lengths become equal to each other. What else could I use here? I think that's really it. Some other constraints, notable, that I can't really use in this scenario is coincident. I'll just make some other lines. So let's say I had these two lines. Coincident is probably the most simple constraint and lets you kind of have two bodies share the same location in space. So for example, these 2 points, if I were to make them coincident, they now share the same location in space. They just connect to each other. You can also use, I don't know, two circles, for example, they will be touching each other as well. Yeah, those are all the ones I'm going to go through right now. Again, you can use the learning pathways on Onshape to get familiar with the rest of these because they are very important. Just can't use them right now. Not applicable. Okay, so I'm going to go ahead and finish up this shape here. So let's see here. So it looks like I want a finger hole here. And I'm going to let Onshape start auto-correcting here with the constraints just because it's very helpful. You can see that it's kind of giving me these suggestions, and I'm going to go ahead and listen to it. So it's making that perpendicular, making this parallel to that line, and we can kind of just go through, and there we go. So now we have a fully enclosed shape, which we can now work with in the 3D space. But as you can see, we're still missing some features. So I'm going to go ahead and go through those. And I haven't even dimensioned anything yet. So, but let's see here. So what am I missing? Oh, well, these need to be parallel. Okay, let's see. I'm just moving it around, seeing what kind of constraints I need to add. Okay, so it looks like everything needs to be constrained is constrained. However, we're still missing some dimensions, right? The things aren't the length they want to be. And if I'm going to go ahead and 3D print this, well, like these could be 3 feet by 3 feet, and that would be way too big. So let's go through the dimension constraint, which is arguably the most important constraint, and it's up here. What this means is you select a body or maybe a distance between two bodies, and you can just set a distance for that. So for example, let's say I want to set a distance between these 2 points. I want to select a distance for this line here. Right now it's 1.46 inches. What I just did, by the way, was I clicked on the line. I just dragged out And I clicked, and then it prompts me to select a dimension. So I'll go ahead and put in, let's say, 0.3 inches, right? And see it got a lot smaller. I can go ahead and just keep constraining these things. So for example, I want this length. You see, actually, the dimensions, they're different based on their perspective. So for example, like this could be from this side and from that side. So you kind of have to keep that in mind where you're dimensioning things, but I'll go ahead and keep going. So I'm going to dimension these two lines. Let's say I want to make them 1.5 inches away from each other. Oh, that's really big. Then let's say I want to make, I don't know, what else can I dimension here? Let's say I want to make this like 1.6 inches. And really what I'm doing is I'm kind of approximating the lengths here. I actually have a ruler here. And you can kind of start to see like, you know, how I'm getting to all of these. So yeah, these are kind of guesses for now. And once you dimension everything, you can kind of start to tell what everything needs to be. So I want this to be about 1.6. And kind of want these to be maybe aligned with each other. Let's say I want this gap to be 1.5. It's really just dimensioning things. It's good practice to dimension things based off of one location, but just for the matter of simplicity here, we're just going to dimension random things, really. All right, let's see, what else can I dimension here? I could dimension this whole thing to be, I don't know, like 3.9. Whatever else we're missing here. And you can see now I start moving this. It's kind of not really moving that much anymore just because so many things are constrained, but not everything yet. So let's say, oops, that's what I wanted. So I want this constraint to be about, I don't know, 0.3. I want this to be about 0.3 wide. Oh, so that's actually a very important thing. So it turned red because something in here is over constrained. So one of our constraints, it contradicts another one, and Onshape can't actually solve this shape. It's not a real geometrical shape. So when something turns red like this, you know that the last constraint you put in, for example, the 0.3, is broken basically, and you can't do that. This is right. So this is set to 0.5 by the nature of these constraints, I think, right? So this is 0.3, this is 3.9, which makes this 0.5, and also using these constraints. So let's see, what else do I need to constrain here? Oh, the length of this. Let's say I want it to be about equal to that. So I'm going to go ahead and set that to 1.5. And we're getting pretty close to our goal shape here. See how points moving around just because it's two lines. Okay, so that looks pretty good, actually. I think now all we're missing, this looks a little bit small, actually. Yeah, so it's a very trial and error process, just get these right constraints. That's fine. So now we actually just need this finger hole here, right there. So that's what we're going to work on right now. And this brings us nicely to construction. I'm going to go over this pretty fast, but it's a very powerful tool. Basically, it lets us create bodies in the sketch, which aren't going to be used in the 3D. Onshape is just going to ignore them. They're just kind of for your reference and let you constrain things off of each other. So how you get to that is you press Q, and then whatever body you want. Or sorry, not Q. You press construction up here, and you press whatever body. So let's say I want a line, and I want to make some construction lines right here. I'm going to go ahead and let Onshape find me the midpoint there using the kind of autocorrect, or you could also use the midpoint constraint up here. And I'm going to go ahead and find a so this is now parallel to that. I think so. And now we want another construction line, which I'm just going to get to by pressing construction and line and getting kind of a cross going on here. And why I need this cross is, well, I want the circle to be kind of in the center of this square, you can call it here. So that's why these construction lines are so helpful. They kind of let me reference things off of each other. So I can go ahead and draw a circle, right? So I press circle. I let Onshape find this point for me, the intersection of these two lines, and I can drag out the circle. Let's say I want the circle to be, I don't know, about 1 inch. Yeah, 1 inch. That looks good. So now we've kind of gotten to our shape. We've used our dimensions, we used our constraints, we used our different bodies to get to a pretty simple but good profile for this tool. And now I'll hand it over to Max to work with this in the 3D space. I'll go ahead and submit the sketch to Onshape by pressing this green check mark, and we get to our 3D environment here. And I'll go ahead and stop screen sharing, Max.
All righty. Okay, I'm just going to screen share right now. Okay, I think this is the right screen. Okay, let's go back. Okay, awesome. Alan's beautiful sketch is now in right here. And now we're just going to turn this 2D sketch, like remember Alan said earlier, design kind of works when you take a 2D profile and make it into 3D. That's always the process that you go through when you're designing a part. And so we're just going to do that to this sketch. We're going to make this sketch into a 3D object. All right, so I'm just going to view normal to here. What I'm going to do now is I'm going to use some of basically the tools that exist in the 3D modeling environment in the 3D Part Studio. So the first one that I want to use is the Extrude Tool. So the Extrude Tool is, I think, the most basic tool in the 3D for 3D modeling. It's just turning a 2D shape into a 3D shape, right? Just extruding it outwards. So, for example, if I just wanted to extrude this, let's say I click this profile because so if you click this tool, the first thing it's going to do is give you this highlighted blue region. It's like in the sketch, like Alan did earlier, that this query box is what it needs for the tool to actually work, and it's asking for faces and sketch regions to extrude. It's pretty self-explanatory. And so you click the profile that Alan just made, and boom, now it's a 3D shape. Just click the check mark for now. Look at that. We just turned a 2D sketch into a
Max, sorry to interrupt
object.
you. I think you're screen sharing the wrong thing.
Am I?
Yeah, you're screen sharing the Notion page.
Oh, my bad. Okay, let me just redo that. Sorry about
Eric,
that, guys.
correct me if I'm wrong, but I think he is.
Probably am. Sorry about that. Okay, is this better now?
Yeah, that looks better.
Thank you for that, Alan.
Yeah, no problem. I'm just a little bit confused where all the extrusions are coming from.
Yeah. Sorry about that, guys. Okay, let's do that again. Let's start all over. Okay, so we got this epic 2D sketch. Let's use the Extrude Tool. The highlighted blue area is what you need to fill in for the tool to actually work. It says faces and sketch regions to extrude. Perfect. Let's click the sketch that Alan made, and there we go. This is what I was talking about. This exemplary, beautiful, exquisite piece of 3D modeling. And okay, but it looks so thick, right? Alan, hold up your 3D printed thing.
Oh, yes, sir.
It's a little wide. It's a little chunky. Okay, let's make it more realistic. Let's say 1.25. Okay, that looks about right. Okay. Yeah, that's about right. Okay, now let's great. So this is kind of the body of it, but we want to make it more like the thing that Alan printed, right? So Alan printed, there's a lot more there's a couple more details to add, and let's start off with that little keychain hole, because one of the really cool things that I thought about Alan's design was that it had a keychain hole, right? So you could put it on your belt or your keychain and just carry it around. So let's actually just go back into the sketch and add a hole, because then I'm going to show you guys how to use the hole feature. Let's go, let's make a point here and let's dimension it. So I'm going to use the dimension tool and just dimension this point in context to these walls. Let's call that 1.135. Oh, let's not do that. 1.0.2. Okay, 0.2. That's good. And let's do the same thing over here for this wall. 0.2. Looks good. Alrighty. Press check. And if you see here, the sketch doesn't exist anymore. By default, what Onshape does is that whenever you extrude something, it'll hide that sketch. So if you want to see that, just there's a little eye over here. It's very, very helpful. You can click the eye, hide it, click it again, show it again, and there's the point that we just made. And we want to make this point into a hole, right? So there's actually a tool just for that. It's called the hole tool. It looks like a hole. and you click the hole tool, and then the blue query box that it'll give you, there's actually two, but let's stick with the first one first. And it says sketch points to place holes. We got a sketch point to place a hole. Perfect. Let's click that sketch point. And boom, a hole has been made. That's pretty perfect. Look at that hole. That's a nice hole. I like the hole. Okay, and then all of these different settings are for different types of holes. You don't really need to know exactly what they are because we need to really get through this, get through all the tools that you need to know. So you can play around with these specific configurations on your own time. Just know that this is the width of the hole. So by default, it was 0.125 for me. If I wanted to make it a bigger hole, I could select 0.25. That's a pretty big hole. Let's make it a little smaller again. I think 0.125, 1/8 of an inch is pretty good. And this is depth of the hole. So imagine if this profile was extruded 30 inches instead of 0.25 inches like we just did. So if it was 30 inches, it was way over there. Then this hole would just barely go through the object. So this is the depth of the hole that is extruded. So 30 inches is the default. You can make it however long and short you want. I can make it 1 inch. It would still be the same because this is only a 1/4 inch, and 1 inch is greater than a 1/4 inch. So, and then this is the second query box. This is the merge scope, and what this means, maybe the name implies this, but it's the scope of which this feature will merge with. So, we selected part 1, right? This is part 1. This is the 3D object we just created with that extrude tool. And so we want the hole to merge with this part. If I maybe clicked off of this, then the hole would disappear, right? Like it wouldn't know what objects to actually go through. And so that's why you need to select the objects you want the hole to go through in order for it to actually register. Let's click that. That's a good hole. Let's save it there. Okay. Let's also now talk about the fillet tool. This is the fillet tool. It looks like a rectangular prism with a rounded edge, and that's what it does. It rounds edges. It makes edges not sharp and safe to use. So Alan, can you hold up your thing again?
There it is.
Amazing.
Oh,
okay.
There it is.
So it looks like we want to fillet this edge, this edge, this edge, and this edge. Yep, those look like okay, and so basically in the query box, it asks for the edges you want to fillet, and so that's why I selected the 4 edges that Alan's model filleted. And so what this does, it just as the graphic represents, it smooths these edges by a certain radius, which you can control here. Let's actually set this to like 0.4. I like that. It's more of a curve, or maybe 0.35. There we go. Give us a little more thickness or whatever. Okay, perfect. Now that's the fillet tool. So it just smooths edges. It's nice for if you want smooth edges, or if you just want to not have like a sharp edge on something, just for safety concerns or something or whatever. So that's what the fillet tool is generally used for. Let's also go use the chamfer tool. This is the chamfer tool. It's right next to the fillet tool. It looks pretty similar, except you can notice the chamfer actually has a flat edge instead of a curved edge. So you might assume that it's gonna cut a chamfer into it, which is what it does. It just cuts a flat surface into this edge. So where it once was this square-like shape, now it's like a pentagon, I guess, because it cut like a flat edge to it. And like the fillet tool, you can also change the distance and the radius of the chamfer. 0.4. I kind of like that. That looks pretty good. Remember, I think, Alan, correct me if I'm wrong, but this little nub is supposed to click like elevator buttons.
Right. Yeah. So it's like kind of I'll demonstrate.
Okay. Live demonstration.
So yeah. So I'd be holding it like this, kind of through the finger hole, and then I could use this point here to kind of click on L button or maybe click a keypad. I don't know, just whatever you don't want to make contact with. And
right. Yeah. Okay, then perfect. So if that's the case, then we want to make it pretty small, right? So you can get those very delicate keypads in some cases. So I kind of like the size. This is a good size. What was that radius? That was 0.4. Yeah, that's a good size. Let's leave it like that. Okay, great. So we have that chamfer down, what else do we need? I think we're good. I think we're good in making this model, but there's some more. There are some more tools I kind of want to showcase. One of those being the shell tool. So this is in the same sort of group as the fillet and chamfer tool, and it looks like you just kind of cut a bit out of a cube, and that's kind of what it does. Like if you click this, it'll ask for faces to remove. Let's click this face, for example. Oh, okay, hold on. Let's make the radius. I'll show you guys a little better what it does. Oop, 1.125. It's gonna give me a second. Okay, well, so what it does, right, is it basically hollows out a point. There we go. Okay, it hollows out a face. So where if I like let's click this. Okay, so previously, right, it was a flat filled in face, right? There was none of this fancy nonsense. And what I did with the shell tool was that I made it hollow. So what this can be actually used for is like when you're making boxes, right? If you extruded out a cube and you want to make it turn into a box for whatever reason, you can use the shell tool. You can just click the top of the cube and then shell it out. It's really, really handy for that. So it's probably not that useful in our case because this looks a little fragile actually, with all this thin walls and such. And you can control the wall thickness over here, shell thickness. That's just how thick the walls you want to be. If you increase it beyond a certain amount, it's going to cause an error, right? Because this is only 1/4 of an inch thick, and so if each wall is 0.15 inches thick, that means that the total width would be 0.3 inches thick, which is more than the actual width of the optics. So that doesn't make any sense. It's not going to be able to do that. So you want to make sure it's actually underneath that amount. So I think, yeah, this is not going to be part of our final product anyway. So we can just delete this. And yeah, that's the shell tool. Let's talk about the Revolute tool. The Revolute tool is not super useful in our case again, but it's going to be super useful if you're making anything like that has rotational symmetry. So the Revolute tool right next to the Extrude Tool, click there, and it's going to ask you, just like the Extrude Tool, faces and sketch regions to revolve. So you can click this sketch region, and then it's going to also ask for a revolve axis. This is the axis of revolution on which that face will revolve around. So let's click the spine of this handy button pressing COVID key tool. Whoa. Okay. Yeah. So as you can see, it literally revolves the profile around that axis, and it creates this like dumbbell looking thing. Okay. So this tool is useful if you want to make it like a cup or like a vase or a cylindrical a cylindrical object. It's going to be really easy to just select a profile and then revolve it around whatever axis you want. So just putting it out there, that's a really useful tool. We use it a lot. It's really great. Great. And then let's talk about the transform tool. This is the last tool I really want to talk about. It is located right here. It just looks like two kind of cubes being transformed around, and you click there. It's going to ask you for an entity to transform or copy. It's just asking you for like a part or a sketch or just anything that exists in this part studio that you want to move around or rotate, copy, whatever. So let's just select this. Let's select that part we just made. And then this is actually where I kind of want to talk about the different options it gives you, because these are the options that define how the transformation is going to occur. So obviously it gives you a lot of options. You can translate it a number of different ways. You can move it around, you can rotate it, and then you can copy it in place and you can scale it. I think the easiest one to show off is scaling. So you can select scale. It's going to ask you like a point of reference. So like, let's just select the point that we drew for the hole. And then this is the scale quantity, the scale number. So that's the scale factor. That's the term. And so let's make it twice as big. Let's make it maybe have big hands. Okay. 2 times as big. Whoa, that's pretty big. That is pretty big. So it scales up from that point we just selected, and it makes the whole everything twice as big. So it might be useful. Maybe you made the part too small. Maybe you want to make multiple multiple like sizes of that product for accessibility reasons. This is the tool for you, the transform tool. Let's delete that. Let's make it normal size again. Great. All right. This is kind of like what I wanted to show for making a 2D sketch into a 3D object. Let's talk about just before we move on to assemblies, I was going to move on to assemblies, but I just want to show you guys what we've been doing here. This over here is called the featured tree. It's really, really helpful because it shows you exactly what you've done, like what features, what tools and features you've used, and in what order, because order doesn't matter. Just, because this extrude depends on that sketch. So if you move that sketch, you can move stuff around. And if you move that sketch after this extrude, then it doesn't make sense, right? Because you can extrude something that doesn't exist. So this has to be before here. And just make sure you understand that this is kind of a really important way you can manipulate your part studio. Great. Let's move on to the assembly. Hold on, where's the assembly? There it is. Okay. Assembly, as I mentioned before, is where you put parts together. You make all these different parts in the part studios, and you want to have them interact with each other in a in a 3D space. This is where the assembly comes in. So let's insert our parts. Let's move our parts from the part studio to the assembly, and that's this button. This is the insert button. You click it. It brings you to this menu. You can select your current document or other document. Usually, you probably don't have other documents if this is your first time using Onshape. So let's stick with the current document. And this is our part studio. We want to select part 1. That's the part we just made. Perfect. Okay, so if you can see here, we can actually drag this part around as much as we want in 3D space. It's just how, it's one of the differences between assembly and part studio, because in part studio, you want it to be fixed so you can actually model upon it, make sketches, identify profiles, etc. But in assembly, it really focuses on how different parts interact with each other. So to demonstrate this, I actually made a quick door handle before this presentation, just to show you guys. So obviously this tool, the purpose of this tool is to to open door handles without, and I guess press keypads too, without making contact with them, because door handles are dirty, they're gross, they're icky. Okay. And how are we going to get this guy to interact with this door handle? There are tools called mates in assemblies. There aren't any extrusions or sketches, but there are different mates and different mating relations. We're going to stick with mates today. Mates, the first mate on this bar, which is the most basic mate, is the fastening mate. It just over here, you click it. Great. It's going to ask you for mate connectors. What are mate connectors? So mate connectors are actually designated points on the object that you can have multiple objects interact with. So if you just hover over any face, you can see different things pop up. Let's say let's just select this one. Hold up. Select this guy, and then let's click over here and let's select this guy. Okay. And then there's you need 2 mates, by the way. You need 2 mates to have so it's 2 mate connectors to have a mate, right? Because you need at least 2 points on which that you want to interact. So you select these 2 mate connectors. Now it moves this in this orientation, and there are options that you can do to rotate it. Let's rotate it like this. There. It's just this button right here. It's also up here. This is another UI, I guess, option that you can use. And so, yeah, let's rotate into the correct orientation. Bam. Wow. This looks like how it would work in real life, right? You would just kind of push down the door handle and it would open. Perfect. And so, as you can see here, I can no longer separate these 2 objects, right? They're all constrained to each other. But I can move these together, but I can't move them separately. And so that's what the fasten mate does. It constrains the X, Y, and Z axes. So it secures them together at these points we just identified. So yeah, that's just kind of the fasten mate. There are a bunch of other mates. There's the the Revolute mate, all these different ones that constrain the X, Y, and Z axis in different ways. Like the Revolute mate, for example, this one right here, it will constrain the X and Y axis, but will allow the Z axis to rotate. So stuff like this. You can play around with this in your own time. They're super intuitive, and if they aren't, feel free to reach out to us on Discord. Feel free to check out the Onshape learning pathways that exist for Onshape.
Yeah, actually, Max,
they're
sorry to
really
cut you
helpful
off, but I
tutorials.
wanted to talk about those pathways just because we have a little bit of extra time.
Oh yeah, sure, let's do it.
Yeah, here, let me start screen sharing really quick.
All right.
Oh, that's not. Let me start screen share. Give me 1 second. Okay. I think I should be sharing. Right, so I cut Max off, but this is the Onshape Learning Center. And as I was mentioning before, this presentation was really, really fast paced, probably hard to keep along with and remember all the tools. So if you do want to use CAD as a supplement to your submission, again, very good idea to boost your score and get that $100 top prize. You can use these Onshape learning pathways. The one we recommend, you go to self-paced courses, learning pathways, and Onshape, I believe it is one of these. It's not this one. Sorry. There we go. It's this Onshape Fundamentals CAD. Right. And so this really is basically a free course on Onshape that takes you through the basics of sketching, which we kind of went over again very quickly. Part design, part studios. So if it's kind of 3D, then assemblies, multi-part, and basically goes through everything. I think if you complete this course right here, I don't think it should take you too long. And if you were to complete it, you could really make a very powerful supplement to your submission that could really boost your score. So again, this does exist on your Onshape account. It's free. Your Onshape account is free. So if you do want to go ahead and use Onshape with your submission, this is a great idea. Again, you can always ping me, Max, Abby, David. We've all CADed. We can all help you with using Onshape and getting through these pathways using all the tools. So that's absolutely no problem. So yeah, Max, sorry to cut you off. I'll go ahead and let you keep going.
Right. Yeah. Hold on. Give me a second. Let me just. Am I working? Is it working? Hold on.
You are not screen sharing.
Okay. Is this the correct screen?
That is the correct. Yeah, it's the document.
Perfect. Let's say that was first try. Okay. Right. So we just, Alan, thank you so much. That learning pathway stuff is really helpful. I learned Onshape on the learning pathways. I think Alan also learned on the learning pathways. They're super, super helpful if you want to kind of go deeper than the very basic stuff that we covered today. Yeah. Well, that's all we wanted to really showcase today. There is so much more that exists in Onshape. You can get into in context, part studios, feature scripts, all these different really complex tools, but those kind of exist outside the scope of the Makerthon for most people. So you guys can go explore those on your own. We just wanted to provide a comprehensive sort of tutorial for those starting out with Onshape and kind of making it as relevant as possible to the Makerthon that's happening today and tomorrow. All right, Alan, do you have anything to add?
Yeah, we can take any questions in the chat if there are any. Looks like Bad Frost 28 say hang in the voice channel to answer any questions. We can do that for sure.
I would love to.
Yeah, if there are any questions, just put them in the chat. We'll answer them, I think.
Oh, it looks like Adwin is asking if anyone's familiar with Siemens NX. So I guess I think from what I've seen, right, Siemens NX has the same basic like tools and features as Onshape with slight different variations, and slight different naming schemes, like slightly different naming schemes as well. I think the main difference is in the sort of UI and the different the slightly different pathway that the program gives the user from sketch to 3D, like turning into a 3D model. So I think Siemens actually has similar plugin capabilities to Onshape. Like I know there's a lot of like different like I think there's like fluid dynamics and um like force diagram stuff to like Onshape. I'm yeah, again, like me and Alan aren't really super familiar with Siemens. So if anyone else is, that'd be really great.
Okay. Yeah, we can wait a second just for if there are any other questions. We'll jump into voice chat after the stream. Actually, to CMD Haro's point, we're doing design reviews. I think it's 7 today. So
yes,
if
sir.
you have kind of a draft of your submission, we'd be happy to look those over. Also, a couple other people are doing it from our robotics team. I think Abby and David were going to do those, or maybe not. I don't know. But yes, Camille, you can get a 1-on-1 meeting.
1-on-1 time. You guys were really rowdy in the chat. Wow. Thank you guys for your engagement, though. That means a lot to us,
Okay, I think we're just about.
Thank you, Badfrost28. Thank you, TextRex4. We're really happy we could present today.
Okay, maybe we can introduce the next panel speaker.
Yeah, I think we wanted to create a 5-minute buffer window,
Right.
just to make sure everything was set up. So we will probably sign off soon. But stay tuned. Our next workshop is gonna be really great. I'm gonna stay on, actually. I'm just gonna listen in. It's gonna be a great experience. I hope you guys stick around for it.